Okay, so let me go ahead and answer that question. And so let's look at the power consumed by this device, this dependent source of ours. So the power consumed by the device is simply given by, so the power consumed by the device is given by V naught ID. Okay, so this is V naught, and the current coming in here is ID. So in this case, the current coming into the positive terminal is positive, and so therefore V naught ID is the power consumed by the device. Now, in region A, V naught is greater than 0. Okay, so in region A, the following is true. In region A, V naught was greater than 0. Okay, so in region A here, V naught is greater than 0. And so therefore, V naught ID is positive, and so therefore my voltage controlled current source consumes power. Okay, not surprising. The power consumed by my device is V naught ID. And if V naught is positive and ID is positive by this equation here, so when VI is positive, and notice VI is positive here, greater than 1, ID is greater than 1, ID is greater than 0, and so V naught ID is positive. So the VCCS consumes power. But then something very strange happens in B. As soon as VI increases beyond a point, V naught becomes negative. Okay? When V naught becomes negative, so when V naught becomes negative, becomes less than 0, then something very strange happens. V naught ID becomes negative. Okay, in other words, when V naught is negative, V naught ID is negative, and so therefore the VCCS suddenly, from being a net consumer, suddenly appears to be supplying power. Okay, so suddenly, as I keeps increasing, this abstract dependent source suddenly, from being a net consumer of power, suddenly begins to supply power. Okay, now as long as it's an abstract device and follows this equation, things are fine. Okay, notice that this equation here did not say anything about the voltage across the dependent source. It simply said the dependent source current relates to the input voltage. Okay, it said nothing about the voltage across the dependent source. And in a situation like that, the mathematical behavior is true. And so in this region, the device would go, V naught would go negative, and the device would continue to behave as designed, and it would begin to supply power. Okay, so mathematically that is correct, just that here it consumes power, and out here in this region, and in this region, it supplies power. So for a mathematical device, that's what happens. So if our VCCS is a device that can supply power, in other words, if our VCCS is not a passive device, okay? In other words, if it is a device that can supply power, okay, or it can amplify power, if it's a device that can amplify power, in other words, if it's not a passive device, it is a device that can amplify power and can supply power, then the mathematically predicted behavior will be observed. There's no surprises, and V naught will go negative. Okay, the mathematically observed behavior will be seen. Okay, no surprises there. Okay, but the VCCS must be a device, a dependent source must be a device that can supply power. Okay, it must be able to cause V naught to go negative and still be able to afford a positive current. In other words, it is supplying power. But supposing our VCCS is not a device, is not a passive device. Okay, I'm sorry, if a VCCS is a passive device. Okay, in other words, if it is a device that cannot supply a power gain. Okay, if it cannot supply a power amplification or a power gain, then in a situation like that, something strange, something else must happen. Okay, so if a VCCS is a passive device, if it cannot afford a power gain, then something interesting must happen. Okay, so out here, as the V naught falls, something must happen here. Okay, something very interesting must happen here. And we'll show you a demo in a little bit as to exactly what might happen out there. Okay, so let's think about it for a second. What must happen out there? Okay, let me pause for a couple of seconds while you think about what might happen. What do you think might happen out there when I have a passive device?